Welcome back, students. In this session, we are going to do some important derivations of general solution. Let's assume sine theta is equal to 1 by 2. Which value of sine is 1 by 2? You know it is already sine of pi by 6 is given by 1 by 2. Let's assume pi by 6 as alpha. So equation becomes sine theta is equal to sine alpha. Hence, I can say that sine theta minus sine alpha is equal to 0. We know already that sine c minus sine d is given by 2 cos of c plus d by 2 into sine of c minus d by 2. Applying the same formula in this case, we get 2 into cos of theta plus alpha by 2 into sine of theta minus alpha by 2, which is equal to 0. So the first equation becomes cos of theta plus alpha by 2, which is equal to 0. We know cos theta can be equal to 0 only when theta is equal to 2n plus 1 into pi by 2. So in this case, theta is theta plus alpha by 2, which should be equal to 2n plus 1 into pi by 2. The second value says sine of theta minus alpha by 2 is equal to 0. We know that sine theta can be equal to 0 only when theta is equal to n pi. So in this case, theta is theta minus alpha by 2, and which is equal to n pi. Now solving on the either sides, 2 and 2 is getting cancelled. As a result, the equation becomes theta plus alpha is equal to 2n plus 1 into pi. Plus alpha goes on other side, becomes minus alpha. So theta becomes 2n plus 1 into pi minus alpha. Coming on the second value, it says theta minus alpha is equal to 2n pi minus alpha going on other side becomes plus alpha. Then the theta becomes 2n pi plus alpha. So now let's see something for generalized solution. So I can say theta is equal to 2n plus 1 into pi plus minus 1 raised to what exactly? Minus 1 raised to odd number would always give me minus 1. So if minus 1 raised to cube, I would get minus 1 raised to 5, I would get minus 1. So the generalized formula would be raised to 2n plus 1. Hence, equation becomes minus 1 raised to 2n plus 1 into alpha. For second value of sine, the plus 1 is positive. So, theta is equal to 2n pi plus 1 into alpha. His 1 in generalized formulae can be represented as minus 1 raised to the even numbers. Why? Because minus 1 square is plus 1, raised to 4 is again plus 1, raised to 6 is also plus 1. Hence, for generalization it would be 2n. So, in this case, the equation would become minus 1 raised to 2n. So, summarizing both the equation, if you take, you get the constants as 2n plus 1 and 2n in either cases. So, I can say that theta is equal to n pi plus minus 1 raised to n into alpha, where n is the integer. So the 2n plus 1 and 2n symbolizes what? If n is equal to, if n is even, minus 1 raised to n is plus 1, and if n is odd, minus 1 raised to n is always minus 1. So I can say that sine theta equal to sine alpha only then if such condition is satisfied. So I can say theta is given by n pi plus minus 1 raised to n into alpha, where n belongs to integer. Moving ahead, second formula is cos theta is equal to cos alpha. In this case, equation becomes cos theta minus cos alpha is equal to 0. Standard formula is cos c minus cos d. It is given by minus 2 into sine of c plus d by 2 into sine of c minus d by 2. In this case, it becomes minus 2 into sine of theta plus alpha by 2 into sine of theta minus alpha by 2, which is equal to 0. So equation becomes sine of theta plus alpha by 2, which is equal to 0. Solving this, we already know sine of theta is 0 only when theta is equal to n pi. So the value of theta plus alpha is equal to nothing but 2n pi. So the plus alpha going on other side would become minus alpha. The value of theta would be 2n pi minus alpha. The second value would be sine of theta minus alpha by 2, which is equal to 0. In this case also sine theta is equal to 0 only when theta is equal to n pi. So when 2 goes on other side it becomes 2n pi, minus alpha going on other side becomes plus alpha. So the value of theta becomes 2n pi plus alpha. So if I want to generalize this, the only change is in the sign of alpha. So I can say that theta is equal to 2n pi plus or minus alpha, where n belongs to the integer. Therefore cos theta is equal to cos alpha. Then I can say theta is equal to 2n pi plus or minus alpha, where n belongs to z is the general solution. Now the last formula, if tan theta is equal to tan alpha, tan theta is represented by sin theta by cos theta. Tan alpha can be written as sin alpha by cos alpha. By doing the cross multiplication we get sin theta cos alpha is equal to sin alpha cos theta. So in this case, when we change the sign of the equation, it becomes sin theta cos alpha minus cos theta sin alpha, which is equal to 0. We know the formula, sin A cos B minus cos A sin B is given by sin of A minus B. So equation becomes sin of theta minus alpha, which is equal to 0. Sin theta can be equal to 0 only when theta is equal to n pi. So theta minus alpha is equal to n pi, where n belongs to integer. So when you require the value of theta alpha going on other side, it becomes n pi plus alpha, where n belongs to integer. So tan theta would be equal to tan alpha only when theta is equal to n pi plus alpha, where n belongs to integer. Thank you.